Meet Maya. She's in 6th grade, she loves soccer, and right now she's staring at her homework like it just grew a second head. Because right there on her worksheet, smack in the middle of a math problem, is the letter X. Wait, she says, is this English class? Sound familiar? Today we're going to figure out exactly what letters are doing in math, and spoiler alert, they're actually kind of awesome. So what exactly is a variable? Think of it like a box with a mystery number inside. We use a letter, like X or N, to represent that unknown number. The letter is just a placeholder. It's saying, hey, I'm saving this spot for a number we're either looking for or haven't named yet. Any letter can be a variable. X, Y, N, A, Z, doesn't matter. The letter itself has no special meaning. It's just a stand-in for a number. Here's a great way to picture it. Imagine a mystery box. Something is hiding inside, but we don't know what yet. We write box plus 3 equals 7. Well, we can replace that box with the letter X. Now it says X plus 3 equals 7. The X is doing the same job as that mystery box. It's just holding the spot for our unknown number. And here's the cool part. We can actually figure out what X is. If something plus 3 equals 7, that something must be 4. So X equals 4. Now, variables don't always show up in equations. Sometimes they appear in what we call expressions. That's math without an equal sign. For example, 2x means 2 times x. When a number is right next to a letter, that's multiplication. And n plus 5 just means some number plus 5. We're not solving anything yet. We're just describing a math situation. Think of it like saying, double the mystery number, or 5 more than an unknown. Expressions are math phrases. Great question. Why bother with variables at all? Well, they are incredibly powerful. First, variables let us describe patterns. Like if you earn $8 per hour, we can write 8 times h to show your pay for any number of hours, not just one specific time. Variables also help us solve mystery number problems, write formulas like area equals length times width, and they show up everywhere. Science experiments, computer coding, even calculating your sports team score. Variables are math's superpower. Okay, let's try Maya's first homework problem together. The equation is x plus 5 equals 9. We need to find what number x stands for. Ask yourself, what number plus 5 gives us 9? Let's count up from 5. 6, 7, 8, 9. That's 4 steps. So x equals 4. Let's check. 4 plus 5 is 9. Yes, that's correct. Maya just solved her first variable equation, and so did you. See? X isn't scary at all. It's just a mystery number waiting to be found. Maya's next problem says, a store sells stickers for $3 each. Write an expression for the total cost. Here, we don't know how many stickers someone will buy. That's our variable. Let's call the number of stickers n. If each sticker costs $3, then the total cost is 3 times n, which we write as 3n. Notice we don't put an equal sign because we're not solving, we're describing. If someone buys 5 stickers, we plug in n equals 5. 3 times 5 equals $15. The expression works for any number. Here's a skill that's going to save you so many times: substitution. That's just a fancy word for plugging a number in for the variable. Say we know n equals 3. We can evaluate any expression. Take n plus 7. We replace n with 3, giving us 3 plus 7, which equals 10. Or try 4n. That means 4 times n. Replace n with 3, so we get 4 times 3, which equals 12. Substitution is like solving a puzzle. Swap the letter for its number and calculate. Easy. Let's work through this with Maya. She sees, evaluate 5y plus 2 when y equals 3. Step 1. Write down the expression, 5y plus 2. Step 2. Everywhere we see y, replace it with 3. So 5y becomes 5 times 3, and we keep the plus 2. Step 3. Multiply first. 5 times 3 is 15. Step 4. Now add. 15 plus 2 equals 17. So when y equals 3, the expression 5y plus 2 equals 17. Maya did it. Remember, always multiply before you add. That's the order of operations kicking in. Now, let's try a slightly trickier one, solving for the variable. The equation is 3n equals 12. This asks, 3 times what number gives us 12? Think about it. 3 times 4 is 12, so n equals 4. Another way to think about it, if 3 times n equals 12, we can divide both sides by 3. 12 divided by 3 is 4, so n equals 4. Let's check. 3 times 4 equals 12. Correct. Maya is on a roll. She's solved 4 problems now. You're right there with her. Here's something cool. You've actually been using variables for a while and maybe didn't even realize it. When you calculate area in science class, you use A equals L times W. That's area equals length times width. 3 variables in one formula. Or distance equals rate times time. These formulas use variables because they work for any numbers you plug in. Any rectangle, any road trip, any speed. Variables make formulas flexible and powerful. Now every time you see a formula, you'll recognize the variables. Maya's class is measuring the school garden. It's a rectangle that is 6 feet long and 4 feet wide. She needs to find the area using the formula A equals L times W. Step 1. Write the formula. A equals L times W. Step 2. Substitute the values. L equals 6 and W equals 4. So A equals 6 times 4. Step 3. Multiply. 6 times 4 equals 24. The area of the garden is 24 square feet. See how the formula used variables as placeholders, and then we swapped in the real numbers? That's the magic of variables in action. Look at how far we've come today, and look at Maya. She started this lesson totally confused, staring at the letter X like it was from outer space. Now she's solving equations, writing expressions, evaluating formulas, and impressing her whole class. Here's the quick recap. Variables are just letters holding the spot for unknown numbers. Expressions describe math situations. Substitution means plugging in a number for the variable. And formulas use variables so they work for any values. From confused to confident, that's the variable journey, and you nailed it too. Keep practicing, and variables will feel like